Okay, this is actually video 3 now, and we were analyzing in the previous video the inverting op-amp where we had an infinite open loop gain. Now we're going to return and analyze this with a finite open loop gain. So I suggest before you look at this, you actually derive it on your own, and then you watch the video afterwards. Okay, so AOL finite. In this case, instead of using KCL, which I could, let's use the other method that I mentioned that we could use to analyze this type of circuit, and that is where I use really superposition to compute the voltage at V minus. We have an input here, VI, fed to V minus through R1, and we have a output VO that is fed back through R2 to V minus. And we have over here, say V plus, which is tied to a voltage VP. And the voltage in between here is delta V equal to VO over AOL. So I'm going to write an expression for V minus as a superposition of VO and VI, and this is just a simple voltage division. So turning VO off, we see that V minus would be equal to VI times R2 over R1 plus R2. And turning off VI, we would see that VO is equal to R1, or VO would contribute to V minus according to R1 over R1 plus R2. Now we could write a statement where we would say that we note that V minus plus delta V is equal to V plus. All right, that's the same thing as just defining V plus or delta V as being V plus minus V minus, which is by definition what delta V is. But now I have this expression for V minus, and for delta V, we're going to write VO over AOL. And for V plus, we have VP. So let's do that. We will have R2 over R1 plus R2 times VI plus R1 VO, I'll put that all over this common denominator, plus VO over AOL is equal to VP. Okay, now it's just a matter of collecting terms. So we'll have VO times R1 over R1 plus R2 plus 1 over AOL is equal to VP minus R2 over R1 plus R2 VI. So VO will be equal to 1 over R1 plus R2 plus 1 over AOL times VP, okay, minus, that's a messy statement, let's try to simplify that. We'll say R2 over, and then we're going to multiply through by the sum of R1 and R2 to arrive at R1 plus R2 over AOL for the second term, times VI. Now we just need to clean this up a little bit. So we could multiply through on the first term by R1 plus R2 as well. So we'll have R1 plus R2 over R1 plus R1 plus R2 over AOL times VP minus, well, the second term I'm just going to rewrite. Okay, and we can check our result by considering if AOL goes to infinity. And we see that for the first term, if this happens here, then this guy will go to 0, and this guy will go to 0, and we will end up with our R1 1 plus R1, R2 over R1, Vp minus R2 over R1 times Vi. And that's what we found before.